Alright, now we're going to begin a lesson on transistors and motors. We're going to learn about how transistors work and how we can use them to control motors. So we'll get into Transistor Basics, we'll do hardware assembly and coding for and controlling a motor. Transistor Basics. Transistor is a semiconductor consisting of three parts: an emitter, a base, and a collector. Alright, so this is one side of it, it flips the other side, there's a definite front and back. Make sure that you're not picking up the temperature sensor in your Arduino kit. They look very similar, but they have temp written on the back, and your transistor will have something a code like this. Okay, now let's talk about what the emitter, base, and collector do. Transistors, like we said, are branch semiconductors, and they allow, sometimes they're conductive, sometimes they're not. That's why they're a semiconductor. And what happens, collector holds back energy. The base, you hit it with a small charge, will open the collector, allowing all the energy going out the emitter. So that means transistors do two things. They are on and off switches, and they allow you to control more energy than what your system normally has. Let me show you off of Instructables by JDog, made this very nice little flash presentation that shows you what we're talking about. So here's 500 milliamps, this 5 milliamps, and then so you get a total of 505 milliamps. So with just 5 milliamps, you can open this gate that allows 500 milliamps to come through. Alright, so it allows a little bit of energy to use a switch to open up for larger amounts of energy. Alright, let's get back to that. Okay, let me go back. Alright, so in case of transistors, of the transistor semiconductor, only allows electricity to move if there's a charge at that base. Remember, we just said there's the base, there's the emitter, there's collector. Think of a dam, there's a great amount of water, a little bit of energy, we move this, we open the dam up. Alright? If we turn the switch on by adding a little bit of energy, all that water was held back, goes down, and goes out the emitter. And there's the electricity begins. We're also going to use a component in diode, which we've been using diodes. We've called them light emitting diodes. This one doesn't. And what this has is a very distinct polarity. You can go only in one direction with the diode. Alright, here's our hardware assembly. We're going to have the diode outside this DC motor. Then we have a pin coming off, pin 9, off our breadboard with the resistor going in the transistor. So this allows us, and there's a ground, and as you can imagine, we're going to put a little bit of charge in this pin 9 into the transistor, which opens up energy and things for the 5-volt motor. So here's the hookup for it. Get ready, go ahead and pause it after you've paused it, and then once you've got everything hooked up according to this diagram, we'll go ahead and proceed in programming it. Just let me go through it with you really quick here. 5 volts coming off the hot here. Ground is going on the blue rail. This is a diode right here, and an important part of that. Here is a 330 resistor, 330K resistor, 330 ohm resistor. Here is the black, or the ground off the off the motor, and then the red off the hot off the motor. And this is our transistor. Notice that there's a straight edge here and it's curved there. So make sure you put it in that orientation. Okay, go ahead and do that, and then come back, pause this, pause it, do this, and then move forward. All right. Now, programming. All right, first of all, we're making constant this time. We could have just made it constant, integer, that's what it's going to be. Motor pin equals 9. That means constant's not going to change. So we have void setup, pin mode, motor pin 9 is an output. This tells us we're going to control the motor. Then we have void loop, and we're going to use some functions in this. Motor on, then off, motor on, then off with speed, motor acceleration. Well, let's look what these variations in code do, what do these functions do, and this motor on, then off, like a blinking LED. Motor on, then off with speed, it alternates between two speeds, and you can affect the timing judging of this. And then this motor slowly starts you accelerating. So these are some of the functions. All right, so here we go. We're going to make our own function here, motor on, then off. But let's start off with void setup, pin motor output, void loop, motor on, then off. That's the function we're going to call. Notice there's a semicolon. There's in parentheses to say, hey, this is a function. There's a semicolon. Then we go down to the function, motor on, then off, parentheses, parentheses, bracket, bracket. All right. And then you have integer on time for 3,000, integer off time for 3,000. So it's 3 seconds. So you digital write. So that's either going to be high or low. Remember, on or off because it's digital. It's not analog. Digital write, motor pin high. Delay on time, which is in this case 3,000. Digital write, motor pin off. Delay off time 3,000. Now you can change that and adjust those on and off times. Because they're digital writes, it's either on or it's off. All right, take a moment to write this code. Get your program to work where it turns the motor on and off. Give it a name. Save it as a name that makes sense to you. Okay. And then once you get that working, let's go on to the second one. We will make a second program that will get a different name as we start to learn some of these functions and making functions and using these functions, I should say. All right. Sometimes this is helpful when you're running programs. It's sometimes good to run void setup, container, void loop, just to clean out what you just did. It's a great way to make sure Arduino doesn't have a program or remnants of another program in memory. That's just a little bit of a tip. All right. If you're really having problems, you think, man, which program is it really running? Just go ahead and run this once. Just void setup, void loop. The program will run. And you have to have it or it will not run. All right. Now we're looking at motor on, then off with speed. So here's a new function that you're going to make. All right. So we have motor pin equals 9, void setup, pin mode, motor pin output sets up the motor pin to an output, void loop, motor on, then off with speed, void, we're calling this function, motor off, then off, motor on, then off with speed. See, when we call a function, we put parentheses, semicolon. Here we're making the function. This as opposed to a library of new functions or functions that automatically come, like delay automatically comes with Arduino code. Or you have a servo that you've gotten because you have a library. This we're making ourselves. So we have integer speed 1 equals 200, semicolon. Integer time 1, 3,000, speed 50 is your time 2. Now we're going to have two different speeds here. So that if there's different speeds, it can't just be digital because there's only one. It's on or off digital. So at analog, different speeds. So we have analog, right, motor pin. Oh, motor pin is pin 9. Notice that's pin 9. That's a pin capable of pulse width modulation, which we learned about in LEDs and allows you to give the effect of giving a power duration of making the lights look dim, they get slowly brighter, and they get dimmer again. We could kind of do those things. We're doing that with speed here. So motor pin. What's speed 1? Well, speed 1, say, is 200. This waits. Then analog right, motor pin, speed 2, and that's 50. All right, and there's delay. So you could set those values to whatever you want as between 0 and 255. All right. So what I would like you to do is be sure to go ahead, save this program as a new name, and then we will do the next function. All right, the next function, we're going to use acceleration. So we're going to say, very similar up here, motor spin 9, output pin, that's all the same. The function this time is motor acceleration. Again, parentheses to tell you it's a function, semicolon. Once you make the function, motor acceleration, you then use these containers. All right, you have integer speed, integer delay time. For speed, starting at 0 until speed hits equals 255, increase speed by 1. This starts to accelerate the motor. Analog write, motor pin speed, sets the new speed, delay time. Then for speed 255, speed go down by 1. This deaccelerates the motor. Then you can do analog write, motor pin speed, delay time. So this really allows you to go up in speed on your motor and then go back down. Can you use a potentiometer or a pot to control the speed of a motor? Let's try to do it on your own, okay? So I would like you to try to build this first and then build it. Hopefully you'll achieve it, and if not, I'll explain it in a few moments. But don't just go forward on this and look ahead and say, well, I'll just do that. This is how you really start to see if you really understand programming, is when you make a program from scratch, not simply look at what somebody else has. It's great in the beginning to look at what other people do. I think it's a great way to start, but I think you need to move over to making your own stuff as soon as you can. Did you use an analog write or did you use a digital write? So review what you did to set an LED brightness using a potentiometer or pot. Did you use analog write or digital write? Can you measure the pot and display it with a screen monitor? Where do you have a picture of a potentiometer that's connected to circuit? So where is it physically you're going to hook it up? Oh, you got that book, didn't you, that came with the Spark Fun? All right, or you could go out there and look. That's the other thing. Don't be hesitant to go out there on Google or your favorite search engine and look what people have put up there. All right, so hopefully by now you set it up. Your motor has stayed pretty much the same since before, but now we've added a potentiometer. Here it is. We've got our ground. We've got the middle wire, this orange output, going back to A sub O. And then we have red going to pot. Whereas in this case, on 9, that is an output, and that helps control that motor. Okay, that's why that's yellow and this is orange. All right, so just all you had to do is add an existing potentiometer. Now you could put this potentiometer in the motor circuit and literally turn it and change the resistance. I'd rather you separate the circuits and use your code to do that. All right. Not surprisingly, we're just going to have a couple additions here. Because I like to be able to see what's going on, I do a serial.begin 9600. That tells me it's going to show up on the screen once I do serial print sensor value. Just real quickly, and then we are going to divide the sensor value, use motor pin sensor value. So let me go up and show you this. So I have motor pin equals 9, sensor pin 0, integer sensor value 0. So those are both 0. Notice motor pin 9 is an output, and sensor pin is an input, and that's an analog input, so that makes a little more sense. Then you have serial begin 9600. Motor pot, that's our function down here, semicolon. Serial print line, so the sensor value, and then print the sensor value. Well, where's the sensor value? Well, we're going to read that sensor value off the sensor pin. Whatever that value is, we're going to write it here. Void motor pot. Sensor value equals the analog read of the sensor pin. So where's sensor pin? That's A sub 0. And that's connected from here back over into A sub 0. Then we're going to take that value and divide it by 4. Well, why do we need to do that? Well, remember, our potentiometer reads from 0 to 1023. Our motor goes from 0 to 255. So by dividing by 4, you now make the value so the motor can use it. So because if the motor went to 1023, it just after 255, it can't read it. The motor only goes from 0 to 255. This allows it to go the whole range. So we have analog right, motor pin. Remember, motor pin is up here is number 9, and then we say the sensor value. So, and that'll be a value because we divided by 4 from somewhere from 0 to 255. All right, if you didn't get working before, go ahead and do this, see where your changes are. If you get it working, well done. Go ahead and save this, give it a relevant name that you'll remember. All right. You could do things, you're using the potentiometer to control the speed of the motor. Hopefully you were able to do that. You could add LEDs to this and make it kind of a light tachometer. If you ever watch Formula One racing, things are happening so fast they really can't look at a needle. So as their tachometer, as the engine spins, that's what the tachometer measures, they use flashing lights. See if you can do the same thing. All right. And here's some other codes that you might want to mess with. All right. So with that in mind, that's all we're going to cover on motor and transistors.